Hey everyone, this is part 3 from Force Class 8th. In this video, we are going to learn about FBD diagram, tension force, effect of forces, pressure. The first one, FBD diagram. Already in the previous video we discussed. Now let me give a short introduction. Here is the diagram. It is FBD diagram, and there are 4 forces acting on the body. Here one is Fn, normal force, Fg, gravitational force working downwards, and normal force working or acting opposite to the gravitational force, so always in the upward direction. And Fe is the external force, okay, and Ff is the frictional force, and Fd is the direction of force. So these two are always opposite, frictional force and external force, and gravitational force and normal force also opposite to each other. Okay, these are the forces are acting on the free body diagram. Okay, yeah. First one, tension. See the diagram here. A weight is hanging, right? The tension is a strain force that is exerted by stretched spring, rope or string. At each end of the tension force acts in the opposite direction to the pulling force. Here you observe the tension force. The force exerted by the string or rope or spring, called what? Tension force. When you hang anything, okay, then the string or rope can feel the tension force. Let me give some other examples of tension force. Here is stretching a rubber band. When you stretch a rubber band as shown in the figure, your hands will experience the tension force. In the same way, have you heard about the tug of war? Yeah, the figure shows tug of war. Here two groups are pulling the rope, right? Here you observe that tension force can see on the thread, and they only feel the tension force because they are stretching, right? They are pulling. Stretching a string or a spring tightly produces tension force. Okay, players experience tension in a string. And next, here a man tried to pulls the heavy or huge or rock or huge object. Here this is the string, okay, and he feels tension force in this situation. Now you know the difference between tension and compression. Yeah, let us observe the difference between tension and compression. Yeah, your triceps muscle when you bend your arm, whether it is tension or compression, absolutely that is tension force. A fishing line holding a fish, also a tension force, because there are some strings, right? Yeah, always stretching down due to gravitational force, right? So that become tension force. And a football being kicked, so this is not a tension, this is compression, because when you try to kick the ball, the air inside the ball is compressed so that the ball can move farther. That's why that is a compression. and a string holding a conker. Already we discussed nothing but tension force. Pushing in a syringe. Yeah, have you tried any time? When you press the piston, the air or liquid, okay, inside the syringe will come out from the nozzle, right? That's why it is a compression. And an arrow in a bow, not a string in a bow, arrow in a bow, that is so that is a compression. It will move some distance, no? Yeah. Your biceps muscle when you bend your arm, this is also tension force. So these are the comparison between a tension and compression. So you can observe some more daily life examples. Yeah. Here another topic is forces can affect things in three ways. Yeah, we can name them. First one, the effect one. A force can change the shape of an object. Second one, a force can change the speed of an object, making it faster or slower. Effect 3, a force can change the direction of an object. And beside examples are also given. We can take so many examples. Yeah. Here we go. Effect of force. Force can change the speed of a moving body. A hockey player hits the ball coming towards him or her, and in this way the speed of the ball can be changed. Or else, for example, uh, you are cycling now slowly. If you want to move speed, then what you have to do? You have to apply more force, right, on pedals, so that you can move faster, right? In this way force can change the speed of a moving body. Or else, if any, for example, if a ball moving on the floor, if you push the ball, it moves faster, right? Yeah, this is also example. Next, force can change the shape and size of an object. Take a sponge into your hand, just press it. You observe that the shape of the sponge will be changed, right? Take a paper, squeeze it, the shape will be changed, right? So force can change the shape and size also. What about the direction? Yeah, while playing carom board, right, or tennis, or badminton, whatever, if you give a sharp hit to the coin with a striker, yes, definitely it will change the direction. Says or no? Yeah. So many examples are there. And the other topic is pressure. It's a very common physical quantity in our daily life. Yeah, definition is given here. The action of force against some obstacle or exposing force distributed over a surface, often estimated with a reference to a unit's area. Is in a simple way in our language. Okay, let me give the definition. A force exerted by a unit surface area called what? Pressure. The force exerted by a unit surface area called pressure. So P is equals to F by A, where P is the pressure, F is force, capital A is area. Understand? And the SI unit of pressure is Newton meter square or Pascal, represented by the letter P, Pascal, or Newton per meter square. This is the SI unit of pressure. very important. Now let me give a shortcut trick to remember the formula. This is nothing but triangle rule. Here by this you can say three formulas. For example, if you want P, pressure is equals to F by A. Yes, one formula is completed. Then if you want to force formula, then force is equals to pressure into A. This is the second formula. Then also you can write area formula with respect to the force and pressure. Okay, force by pressure, understand? So in this way we can write three formulas. This is nothing but the triangle rule. And can you give some examples of devices that you use high pressure? Yeah, absolutely right. You are looking at on the screen. They are scissors, drawing pins, wash, axe and knife. They possess high pressure with lower surface area, because you know the definition, P is equals to force by area. Also we can write pressure is directly proportional to F, pressure is inversely proportional to area. So if area increases, pressure will be decreases. If area decreases, pressure will be more or increases. So that's why here a knife or drawing pins or scissor having a sharp edge have a small surface area. That's why if area is small, pressure will be more. That's why they have a high pressure. Here differences between high pressure and low pressure. uh, Look at, observe these and observe this. Here area will be less, that's why pressure will be more. Here area, surface area is more, pressure will be less. Understand? Already we discussed about the formula. Here the question is for you. Why does the mattresses when sink more when I am standing compared with when I am lying? Here the mattresses sink more than when I am lying on the mattress. So think and discuss, okay, about the reason. And before that, let me ask, you have to do one activity. Take a pen, okay, with sharp edge. Just try to push your arm, okay. How do you feel? Definitely you feel hurts. Reverse it and try to do the same activity, then you feel better than the previous one, because sharp edge have a less area, will be apply more pressure. That's why you feel pain, right? Okay. Next, problems. Calculating pressure. A lady of weight 600 newtons, n is in the sense newtons, this is the SI unit of force, standing on two stiletto heels of area 1.5 centimeter square. Then what is the pressure due to the heels? Here Newton meter square, actually centimeter square is given, no? This problem is some difficult. You have to convert centimeter square into meters square. Okay, then find the pressure. Okay, next some other questions are given to you. You have to solve them. Okay, children, first one, second one, and third one, answer also given. You try them in your notebook. Thank you.